All right, testing if triangles are similar. We are going to look at 3 ways to test if triangles are similar. They can be similar by angle, okay? Now, the reason why it's not 3 angles is because each triangle adds up to 180, and you know that. That means if 2 triangles have 2 equal angles, their third one has to be equal because each triangle would have to add up to 180. An example of this, really quick example of this, is easy to see with equilateral triangles. So if this corner is 60, and this corner is 60 here, and this corner would be 60 as well, this corner would be 60. These triangles have to be similar because both triangles have 2 60s. And the third angle would have to be the remaining of the 180. So we don't say similar by AAA, we say similar by 2A's. So look at these 2 triangles in the box underneath, or look at these 2 examples in the boxes underneath or AA. Let me zoom in. So number 1, if it gives us all angles, we're not interested in the other 2 methods. Look at the other 2 methods. There's a side, and an SAS. If it gives us angles only, we're not even considering SSS or SAS. We're only focused on AA. So how do you tell if these are similar? If they have 2 congruent corresponding angles. Look at this. This is 75. This is 75. I am halfway there. I just need one of the other angles to be equal to each other. Well, if this is 75 and this is 31, I can find this by taking 180 minus the 75 and the 31. And that gets me 74. So they both have a 74 now. So these are similar by AA. This is how we say it. We put the AA in the similarity symbol. The similarity symbol is the wavy line. All right, number 2. I only see 1A here and 1A here. But if you remember congruent triangles, do you remember what happens when it gives us this picture? You remember what these will be called? Anybody remember vertical angles? So this is the second set. So there is your second A. And these will be similar because they have 2 corresponding congruent angles. They have 2 congruent angles. They're similar as well. So this is what we've been working with in class. Side, side, side. Okay, it's pretty easy. This is what we've been doing in class. We've been saying these are similar. You know, we'll say this is a 6. This is an 8. We can say this is 16. And so what will this side be? Anybody see the scale factor already? What would X be? Be 12. So that's side, side, side right there. I just only did it in 2 sides. So I could say this side would be 10. I don't know what happened. And then this side would be 20. So there, we've been working with that already. That's side, side, side similarity. That means each side has the same scale factor. So If each corresponding side has the same scale factor, 6 over 12 is 1/2. 10 over 20 is 1/2. And 8 over 16 is 1/2. If that scale factor is the same in all three sides, then it is similar by side, side, side. Okay? So look at number 8 or number 3 here. This is similar by side, side, side. You should see a scale factor of 2. 3 times 2 is 6. 5 times 2 is 10. 4 times 2 is 8. The scale factor is the same. These are similar by side, side, side. So you're checking to see if the scale factor is the same on every single one. So that means, look at this statement right here. If all corresponding sides are proportional, that means the scale factor is the same. In this example, they all grew by 2. Okay, so let's see if this one's similar. So what we do is we take corresponding sides. 30 and 24, what's that scale factor? 30 divided by 24 is 1.25. So we're going to check if 1.25 is the same on all of these. 35 divided by 28, 1.25, check. These are proportional as well. Now 32 divided by 25 is 1.28. These, the green and blue, are 1.25, but the red is 1.28. That's not allowed. This is a no. They are not similar. The scale factor is not the same. Does anybody have questions with SSS similarity? Side angle side. Now look at the picture, guys. If it gives you two sides and an angle in between them, our only focus is side angle side. That's all you're checking. Look at this picture. I'm not going to check angle angle here. It doesn't give us two angles. I'm not going to check side 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 here because it only gives us two sides. So it needs to give us two sides and the angle in between it for us to test similarity. So what needs to be true here is these angles in the middle have to be equal. Those markings say yes. If they're marked the same way, they have the same measure. If the scale factor from 8 to 6, I'll go ahead and tell you what that is. 8 divided by 6 is 1.3 repeated. That scale factor needs to be true from 20 to 15. 20 divided by 15 is 1.3 repeated. The scale factor for both sides is the same. This is similar by side angle side, and make sure you put a wavy line in. That's why these are similar. So yes, one equal angle in the middle of two sides that are proportionate. They both have a scale factor of 1.3. Number 6, we haven't seen an overlapping picture yet, but this angle is the same on both triangles. In every overlapping example, the corner that you only see once, see this top corner, you see twice. See this bottom corner? Each triangle has a bottom corner, but each triangle is sharing angle A. They are trying to tell you that is a congruent angle. So A is our angle in the middle of our sides. So let's check. Our scale factor for the top side should be 15 on top of 25. Let's check if that is the same as 12 on top of 21. If this decimal, when I divide this, is the same, these are similar. 15 divided by 25 is 0.6. 12 divided by 21 is not 0.6. This is a no. Since these are not on the same scale factor, they are not similar. You have to have the same scale factor in SSS and SAS. On the AA, all you got to do is test two angles. That's it. AAA is the easiest one to work with. All right, number one. Do you see on number one? I am only testing SAS because I have two sides and an angle in between it. I am not interested in AA. I am not interested in SSS. And I put that at the bottom. I'm only interested in SAS. So it's going to be a yes SAS or a no SAS. Yes, they have two equal angles. 3/9, you guys can probably see that that is a times 3 scale factor. And 5 times 3 is 15. That's also a times 3 scale factor. The scale factor is the same. So this is a yes. It is similar because two equal angles and the scale factor in the sides is the same, times 3. This one, I'm only interested in SSS because I'm provided 3 sides. Now, what's really hard here is that sometimes it's hard to see which side goes with which side. So I'm going to do my very best. But I'm going to do my best guess and say 22 should go with 16. 22 divided by 16 to get a scale factor of 1.375. There's my red scale factor with my red corresponding pieces. Now I think 35 and 25 are corresponding. I'm going to check what that decimal is. 35 divided by 25 is 1.4. I'm already finished. These are not similar. The scale factor is not the same. I would have needed to see 1.375 3 times or 1.4 3 times. You cannot have one that's different. And you can't round or anything. It has to be exactly the same. Okay, on this one, I went ahead and put AA because it's only giving us angles. So AA is my only test. If it has 2 equal angles, we're good. If it doesn't have 2 equal angles, then we just simply put no. All right, we know from the picture that it's going to have 2 42s because they're vertical. And then I can take 180 and just work with one of these triangles. I'm going to work with this triangle here and say 180 minus 42 and minus 53, and I get 85. So now we see that each triangle has a 42 and 85, therefore it has 2 congruent angles. So this is a yes. It is similar by AA. Number 6, when they are overlapping, we have to say this angle P is the angle they share. So that is the angle we're using. Now, I'm going to say SAS because this is the only one that has one angle. That is what I'm testing, SAS. You are not allowed to use these 2 sides in our test. Now let me tell you why. Because SAS the angle has to be between the two sides. Now look at this green angle here. That angle is between the sides with an 18 on it and a 15 on it. Therefore, we're testing the top sides and the bottom sides. So the test for the top side is 18 over 24. The top of the small triangle is 18. The top of the big triangle is 24. You guys have all seen this before. The bottom of the small triangle is 15. The bottom of the big triangle is 20. I am testing. Is 18 divided by 24 equal to 15 divided by 20? They are both 0.75. Then this is a yes. These are similar by SAS. Number 5, we'll skip. I'm not going to give anything like that. Number 6, once again, if it's overlapping, I'm always testing SAS. Here's my angle. The left side of the small triangle is 35. The left side of the big triangle is 65. My first fraction is 35 over 65. The right-hand side of my small triangle is 24. And the right-hand side of my big triangle is 44. So I'm going to look at 24 and 44 and test if those are the same decimals. 35 divided by 65. I got 5384, a long decimal. Now let's check. 24 divided by 44. That is not the same decimal. Since these are not equal, these are a no. The fractions have to be equal, and just turn them to a decimal to check. Okay, here we're dealing with only angles. There is no sides whatsoever. So I am only checking AA. I hope that makes sense. There's no sides given. But remember, you can't forget this, that those are 90s. That's a sneaky way to tell you two angles are equal. So just make sure you catch that. So now I can make sure I can find this other angle here. And that other angle, I took 180 minus 90 and 34. This angle here must be 56. Okay, so that would have to equal this one. So this one's not equal, and this red one is not equal. These are not similar because only one angle is equal. They both have a 90, but that is all. They would have to have two angles. Last one on the page. Okay, we're going to test. So we cannot say angle, angle, because no angles are given. We cannot test side, side, side because we're only given two sides. So the only test we're doing is side, angle, side. And yes, we do have an angle because of vertical. Okay? Now this is a hard one too, because I don't know if I want to put 39 on top of 84 or 39 on top of 63. I guess we could make a rule. In all reality, it's easy to check both. I mean, look, if I take 39 divided by 63, 39 divided by 63 is 0.619. Okay? 39 divided by 84 is 0.464. Now, if I take 52 and divide it by 84, or 52 and divide it by 63, and I see one of these decimals, then I have something to work with. So 52 divided by 63 is not one of those decimals, so I don't have anything to work with yet. 52 divided by 84 is 619. Now hold on. 52 on top of 84, I see a 619. Let's make sure and see if 39 on top of 63 is 619, we have a similarity. So 52 on top of 84 is 619. Is that true? Is that true about 39 over 63? It is. Because 619 pops up twice, this is a yes. And that's tough. It's SAS.